Hi, in this video, I will demonstrate how to install Elmer using MPI and including Elmer GUI. On our website, under Sources and Compilation, you will find where to download Elmer source code and the steps to compile the serial version of Elmer without MPI. Now, if you're interested in taking full advantage of Elmer's parallel capabilities, you might be interested in compiling it with MPI. And in order to do so, you will need some additional packages before compiling it. These packages are easily found under Homebrew. And if you're not familiar with Homebrew, I recommend going to our YouTube channel, and under Elmer compilation on macOS using Homebrew, we address how to use Homebrew to download specific packages. Now, since we addressed that in that video, I'm going to go ahead and just let you know what packages are needed in order to install Elmer with MPI. So we will need GCC and CMake, just like we did before. But we're also going to need OpenMPI, the Metis partitioner, and the Scala-Pack library. If in addition you're interested in downloading Elmer GUI, you will need Qt4 and Xquartz. Now, in order to install it with MPI, you will need the MUMPS direct solver, and that will be our starting point in this video. Now, before going ahead and compiling our own version of MUMPS, I will follow the instructions so you see the difference between compiling it for the serial version of Elmer and the parallel version of Elmer. So just like I did before, I'm going to have my instructions to the left and a terminal window to my right. And this will be our starting point. So the first step would be obtaining the source code. So let's follow the instructions. We need to create a directory called Elmer, get in the directory and clone the source code. So that's what we're going to do. And I'm just going to copy this. Now, this process is going to take a couple of minutes. So I will pause the video and resume once I have downloaded the source code. Okay, now that we have downloaded our source code, I'm going to go ahead and get the MUMPS direct solver. So the easiest way would be going to the GitHub repository and downloading this source code. So I'm going to do the same thing, git clone, and I'm going to clone MUMPS. What I like about this repository is that you can compile it yourself for different versions and for different platforms. So if you're, even though this is a specific video that addresses the installation on macOS, this version of MUMPS allows you to compile it on Windows, macOS, and Linux. And here are some general commands to compile it yourself, but I will be just addressing the ones that are relevant to the installation of MUMPS with Elmer. Now that we're done cloning the MUMPS repository, I'm going to go ahead and go into the directory, and I'm going to configure. I'm going to configure the makefile. So here we have the following. We want to compile it for parallel purposes with real arithmetic using the Metis partitioner. We go ahead and we build it. This is not really building it. This will just create the makefiles in order for you to be able to compile it yourself. If you have all the packages that I mentioned earlier, this should be smooth. And now what we'll do is just CMake, and we build it. So once again, this will take a couple of minutes. So I will just pause the video and resume once this version of MUMPS has been installed. Okay, now that we have compiled MUMPS, let's just clear the screen so we can see it better. I'm going to make a library directory, and I'm going to copy everything from the build directory that is a static library. So we're going to just type in this command, and we're going to, so we can list our library, and we're going to see that we have the static libraries that we're going to use in our Elmer compilation. So having done that, we can go ahead, one directory up, and now we're here. So we have MUMPS, and we have the source code of ElmerFEM. So we can go back to the instructions, and we can just resume from here. Now we will just make a directory called build and get into the directory. And now we will just make the respective changes that are needed in order to compile it with MPI. So I'm going to do the same thing I did last time. I'm just going to use the same configuration for the make files, and we'll just edit them so they are adapted to our needs. So in our particular case, now we're going to change a couple of these commands. Now we want to have the Elmer GUI, so we're changing this to true. We want it to MPI. I also recommend installing it with GUI, which is a math library. So I will add this. I will add then the fact that it's with MUMPS. And last but not least, we need to say where our library is, our MUMPS library. So it will be dmumps root. And since we have it in one directory up, we just set it as is. So as you can see now, we're basically keeping the same configuration, except for that now we're adding the Elmer GUI, we're compiling it with the MPI, and we need the MUMPS library. So after doing that, this will configure our make files, and just press return. And this will create the particular make files that we'll need to compile Elmer. This will take a couple of seconds. And here we are. So as you can see, we have our Fortran compiler, our C compiler, C++. We found MPI. And it's also linked to our MUMPS library. And now what we can do is just go to our last step, which would be just the actual compilation of the software. And just clear this so you can see it better. Make -J4 for 4 processes and stop. This process will also take a couple minutes, so I will pause the video and resume once this has finished. Hi, so now this has finally installed, so let's check everything is in order. Let's clear so we can see it better. So the first thing I would recommend is setting up your environmental variables. We did that in advance, so I can just show you. It's under dash profile. So here, this was something we addressed in the other video, which is we don't want to use clan. We want to make sure that we're using GCC. And here is our Elmer installation. So that way we can actually use Elmer on command line everywhere. So I'm just going to close this. And I'm going to show you how to run Elmer in parallel. So I'm going to go, I have an MPI example. And I'm just going to show you a shell, a bash file that we have for parallel computing. So the first thing is that you need to make sure that you use the Metis partitioner for a specific mesh. In this particular case, I'm just splitting it into 2 because I want to use 2 processes. So if I actually run this file, that's exactly what it's going to do. It's going to run first the Metis partitioner and create basically split the mesh into 2. It will ask you for incoming network connections. This will be the first time. And if you have admin rights, it might not ask you that. But if it does, then you just gotta go and enter your information. So here we can actually see that we're using Elmer Solver. And in this particular case, we're running it in parallel with 2 tasks. And we can verify that we have MUMPS and Lua linked to our compiled version of Elmer. I'm going to stop this example just so that we also verify that you can use it with Elmer GUI. So if you are interested in running it interactively, you can open Elmer GUI, which you have in front of you. And it's just so you see how it looks like. We can load a mesh. I can load the same mesh I used for the parallel example, my mesh. And here it will provide all the boundaries and volumes. So for instance, like here, I can hide this and see what we're actually working with. This is a 3D mesh for an electromagnetic problem where we have a coil and a plate. This is from the team workshop, problem number 7. And here you can work interactively, setting up equations, material properties, body forces, etc. So now you're all set up to run it interactively or through command line. And I hope you have a lot of fun speeding up your simulations using parallel capabilities of ElmerFEM. Thank you for watching the video.